Now let's get back to quadrilaterals. Let's examine the properties of each of the quadrilaterals previously mentioned. Starting with the square, we see that in the square, besides having 4 equal sides, opposite parallel sides, and 4 equal angles of 90 degrees each, it also has diagonals that are equal, and that the diagonals are perpendicular bisectors of each other, which means that these segments are all equal, and that these 4 angles are 90 degrees each. Also, the diagonals, besides cutting each other in half at 90-degree angles, they also bisect the corner angles, making angles 1, 2, 3, 4, 5, 6, 7, and 8 45 degrees each. The list of the properties of the square is long, and as we remove some of the properties, the square takes the form of sometimes rhombus, rectangle, parallelogram, or trapezoid. For example, if we were to modify the square by pushing on one side, the square changes the following properties. Diagonals are no longer equal, and although they continue to be perpendicular bisectors of each other and bisect corner angles, all corner angles are no longer the same measurement, and only opposite angles are equal. And we call this new figure a rhombus, whose properties are 4 equal sides, opposite sides that are parallel, opposite equal angles, diagonals that are perpendicular bisector of each other, forming, of course, 4 90-degree angles, and diagonals that bisect corner angles. But if instead of squeezing the square, we stretch the square, then not all 4 sides will be equal, but only opposite sides will be. And both the diagonals will be equal, and all corner angles will still be 90 degrees each, and the diagonals will bisect each other. These 4 segments will be equal, but the diagonals will not be perpendicular, and the corner angles will not be bisected. So instead of a square, we have now a rectangle, whose properties are opposite sides equal and parallel, 4 equal corner angles at 90 degrees each of measurement, equal diagonals that bisect each other, and equal pairs of opposite central angles. If we continue to eliminate properties in the rhombus and rectangle, for example, if the opposite is done now that the rectangle is squeezed or the rhombus is stretched, then a parallelogram is formed. The conditions of the parallelograms now diminish to equal and parallel opposite sides, bisecting diagonals and equal opposite central angles. Gone are the bisecting corner angles, bisecting perpendicular diagonals, right angles, equal diagonals, and so on. The properties of the parallelogram come from the fact that it's made from 2 pairs of parallel lines. If you go back to the section on parallel lines, you will see the same properties, except that the 2 pairs of parallel lines became segments, so that opposite sides are equal and parallel, opposite angles are equal, diagonals bisect each other, and consecutive angles are supplementary. Now, any change we make to diminish the parallelogram turns the parallelogram into a trapezoid. For example, if we change the size of one corner angle along one side only, a pair of opposite sides will lose their parallel properties. Also, if we increase the size of a diagonal the same way, along one side, the same thing happens, and the figure becomes a trapezoid. And the trapezoid will not keep the name if we tinker with one angle along both sides. For example, if we move one angle towards its opposite, this type of move turns the trapezoid into a mere quadrilateral, whose basic property is just to have 4 sides, no matter how it is arranged.